Tonight on Nova, the high-tech weapons the U.S. hopes will win a war with Iraq. With the help of a computer brain, these so-called smart weapons can find a target many miles away and steer in for the kill. But are smart weapons really smart enough? If war comes, how much can we depend on these new, untried killing machines?
Funding for NOVA is provided by the Johnson & Johnson family of companies, supplying healthcare products worldwide. And Lockheed, a bold new force in systems engineering, management, and technology services for defense, space, and industry. Major funding for NOVA is provided by the financial support of viewers like you.
In the northern Arabian Sea, the USS Independence sails within striking distance of Iraq. The carrier and its battle group arrived here in early August, 3 days after the Iraqi invasion of Kuwait. If war had broken out, the Independence and its 50 attack aircraft would have faced an Iraqi force hundreds of thousands strong. Today, the carrier has lots of company, dozens of other ships and 250,000 troops in Saudi Arabia. But the U.S. is still outnumbered, forcing it to seek military superiority not through quantity, but quality.
Even though we're outnumbered at times, the fact that we have better weapons and better training is going to give us the edge in most scenarios. The type of weapons, the precision of which you can carry fewer of them, which means you send fewer airplanes in there to do the job, as compared to years ago when you just had to bomb entire areas because your weapons were so imprecise in what they hit.
Armed with computer-driven weapons and sophisticated communications and intelligence systems, the military hopes to score a quick knockout punch by destroying key Iraqi targets should war come.
Rotate it. Forward. Back.
Technology is there designed to enable you to win quicker. And if it had to be short but violent, that's a better way. Fewer people would end up dying than a war of attrition that goes on for a long period of time.
Some of the carrier's pilots are getting ready for a mission.
Okay, guys, you ready for event 4 brief today? Yeah. All right. We'll proceed up through the corridor into the Gulf, into the Persian Gulf. All right, the target area, everybody's been up there before. All right, is right there on the coast of Saudi Arabia, and clear target area, and we'll go in there and run our target area tactics.
The pilots are at greatest risk. This morning, they'll be flying a practice mission near Kuwait. But in a war, they would be attacking Iraq's air defenses to open the way for other American planes. The difference between success and failure, between life and death, will likely be their new untried computer-driven weapons. The Pentagon has already spent hundreds of billions of dollars in what could be the biggest strategic gamble of the post-Cold War age, using high technology to maintain America's superpower status.
America is basing its security on advanced technology. As our forces shrink, and they will be coming down in numbers, the belief is that we will retain superiority over any adversary by applying advanced technology, which is better for warfighting than any adversary will have.
When we go down in quantity, we will have to go up in quality. And the way to do that is to continue the effort with technology. Again, it will be an effort to stay just a little bit ahead of the other side, or maybe a lot ahead of the other side.
Hellfire. It's many missiles in one. Rockwell International's Hellfire modular missile system is the primary armament for the
For
US
defense
Army's
contractors, at least,
364
the Pentagon's strategy has already paid handsome dividends. At an annual military exhibition in Washington, defense contractors tout their latest high-tech weapons to America's armed services.
Who would you feel your buyers to be?
Well, we've sold it to the Marine Corps in all of our variants. Just signed another contract with
United States Marine Corps and General Dynamics will continue to work together and strive for ongoing success in maintaining a formidable shield against air attack.
It's the defense industry's version of an auto show. Here you can find anything from a helmet that allows pilots to aim weapons with a turn of the head to a missile-firing vehicle that seems to belong in an arcade.
This is very much like a pack game where the soldiers and the Marines of today's armed forces grew up playing video games. And this is a super video game.
These are the killing machines of the computer age. Robotic missiles, bombs, and torpedoes. The U.S. has more than 50 varieties of what are commonly called smart weapons. A smart weapon is smart because it has an electronic sensor that looks for a target and a computer brain that identifies it. Once the target has been identified, the weapon goes in for the kill, adjusting its course as needed. A tank like this is easy prey. Not surprisingly, the development of smart missiles has revolutionized military strategy.
There's a move toward the missile today. Everything is tending to work toward missilery. The ships at sea that used to fire guns now fire missiles at aircraft that are coming in or even at other ships. In the air, the fighter plane that used to have machine guns and maybe bombs has missiles where it had machine guns and missiles where it had bombs, and even the infantryman fires a missile at a tank. It is because of the precision and the penetrability and the simplicity of the missile that things are moving in that direction. Now, along with that, such things as how to acquire a target in the first place and how to spread information about targets, all of that is moving into automation of one kind or another, and especially, of course, the arrival on the battlefield of the computer.
In Florida, one of the most expensive computer-driven weapons ever developed is about to be tested. This is the AMRAAM, a missile with radar vision and a computer brain. Armed with AMRAAMs, one fighter should be able to shoot down 4 enemy planes simultaneously. But after spending billions of dollars, the Air Force has yet to prove the missile can work. The last time it was tested, it missed all 4 targets.
This shot is in fact extremely important. It has all the ingredients of being a pass or fail shot. It seems as though a lot more hinges on this shot than you would want if you had a choice.
I'm about ready to crank.
An F-15 heads out over the Gulf of Mexico.
run in heading 130. Your target is squawking mode 3, 6174.
Metro 1 flight, right 310. Blue 1 clear to arm.
The pilot will attempt to destroy 4 unmanned target planes too far away to see. First, his radar screen picks up 4 dots, assumed to be the targets. Then he assigns 1 AMRAAM to each. Now, the radar in each missile takes over and plots a course to its target.
Zoom 1, cleared to fire. Zoom 1, cleared to fire. Ready, Fox. Fox.
Despite radar jamming and evasive maneuvers by the target planes, all 4 AMRAAMs find their marks.
Great day. It's a culmination of just unbelievable amount of work, and it just feels great.
The hope of the Pentagon is that a new generation of smart missiles will make a shrinking military more effective and save the lives of American forces. With smart missiles, soldiers and pilots don't have to get right on top of their targets to destroy them, decreasing the risk. Today, with less manpower, the idea is to let smart weapons do the job and do it more efficiently.
We wanted to make sure that every shot counted. So we were aiming at trying to get combat power precisely on target. And that meant something smart, maybe something that could fly out there, see the target, tell you about it, ask you, is that the one you want to hit? And you could say yes.
In best-selling author Tom Clancy's techno-thrillers, smart weapons work perfectly and always save the day. In his books, Clancy writes of smart weapons as the latest in a long line of weapons that enable a small force to defeat a much larger one.
Weapons of this type, a repeating high-powered rifle, evolved in the colonial wars of the late 19th century. Small, well-trained professional armies found themselves being attacked by the local natives, who, of course, were really trying to defend their own homes, but who attacked these small professional groups in very large numbers. It therefore became necessary to use a weapon of this type to engage as far away as possible and cut down on their numbers before they got within sword range of the European armies.
In Saudi Arabia, the U.S. will try to use the modern equivalent of the repeating rifle against Iraq. Smart weapons on these A-10 attack aircraft will allow a much smaller American force to battle thousands of Iraqi tanks.
We have enough technology, we feel comfortable that we can stand off far enough to be able to inflict damage on the enemy, but yet survive ourselves.
Each A-10 is equipped with smart Maverick missiles that can home into their targets by tracking the heat they give off. As a backup, there's also an automatic cannon with armor-piercing shells.
If we didn't have the Maverick missile, we'd have to rely on the gun, which would make us come in closer to the target area. The closer you get to the enemy, the closer chance they have to shoot back at you. So the farther away you can kill them, you can get in there, destroy the target, and hopefully not be seen and get back home alive.
It was in Europe during the Cold War that the strategy of using smart weapons to compensate for a smaller force was developed. In a war with the vastly larger armies of the Warsaw Pact, hidden command centers like this one were supposed to direct the launch of smart weapons. Because the U.S. did not have enough men and equipment to fight a long war of attrition, the battle plan called for smart weapons to help win a quick knockout victory. Rather than destroy enemy troops, smart weapons would reach deep behind enemy lines to attack so-called high-value targets, tanks, radar installations, and command centers, paralyzing the foe. The Apache helicopter would be especially busy in battle with its smart laser-guided air-to-ground missiles. It's a prime example of the few-against-many strategy.
An enemy battalion would have 30 to 40 armored vehicles. I would use 5 helicopters, 5 attack helicopters. A tank regiment may have up to 150 tanks. I would use my battalion with 18 AH-64 Apaches and need no other resources to destroy that element.
But that kind of success is only theoretical. These weapons have never been proven in all-out combat, which worries veteran commanders.
We get these exotic, wonderful weapons that on drawing boards and in unrealistic tests look awfully good. But when you put them into the forces and try to operate them in salt water and sand and mud, they don't perform like exotic weapons. Perhaps the key example in front of us today is the Apache helicopter of the United States Army, their most advanced battle helicopter. They can't even keep half of them in the air under peacetime conditions in the United States. How are they going to perform in Saudi Arabia in heat with troops out in the sand?
The Apache is the Army's attempt to build the ultimate tank-killing machine. It can use its computer-driven weapons while flying 200 miles per hour at treetop level. It's so sophisticated that expert technicians must constantly maintain it. But this is the price the Army is willing to pay to be the world leader in high-tech weaponry.
The military has always stressed performance at all costs. This is true of military equipment every place. You go for the ultimate weapon, and the last 10% of performance doubles the cost and makes the material twice as hard to operate and maintain.
But even if that extra 10% does pay off, the truth is that smart weapons are not all that smart. Smart weapons work by recognizing simple patterns. For example, a weapon with a heat-seeking eye looks at a large object like a plane and sees a hot spot. But a blip is what a weapon using radar sees when it looks at the same plane. While a TV seeker sees a dark mass. But none of them can look at a plane and identify it as an enemy fighter or a friendly fighter. Still, defense planners argue that in spite of these limitations, we have no choice but to use and develop smart weapon technology.
I think that it's like anything else, just like the single shot gave way to the repeating rifle, and repeating rifle gave way to the Gatling gun. Horses gave way to tanks. We gave way from propeller-driven to jet aircraft and so forth. If we don't use the things that are available to us, somebody else will, and we'll learn too late.
The concern is not so much that we'll need smart weapons against the Soviets, not as long as U.S. and Soviet commanders meet at receptions instead of on the battlefield. Rather, the robotic weapons of the Cold War will now be used against countries like Iraq.
There is a high level of technology in many, many nations that would not be called actually industrialized nations, so that they do have the capability to acquire missiles or to build them themselves, missiles that can knock down airplanes and so forth. This means that as we look into the future, war is possible between nations that might be very big and powerful and nations that are not so big and not so powerful.
In this corner of the world, a superpower and a small nation did fight, and smart weapons tipped the balance, although not in ways that reassure the Pentagon. These abstract-looking designs are stylized pictures of Soviet tanks and planes fighting in Afghanistan. They are being woven into carpets by Afghan refugees in the border city of Peshawar, Pakistan. The carpets tell the story of a superpower that tried to use high technology to dominate a traditional culture. These are mujahideen, Afghan guerrillas. From small bases like this one, they have been fighting the Afghan government. But from 1979 to 1989, they fought the Soviets for control of their country. When their struggle began, the Mujahideen were completely outgunned by 100,000 Soviet troops. The Mujahideen come from a society far behind the industrialized world, a culture not of microchips, but mud bricks. Abdul Haq became a Mujahideen commander as a teenager. When the war began, he was able to frustrate the Soviet forces by using simple tactics plotted with toy soldiers in a sandbox.
I'll just give you an example. Like we have here a small camps of 50 people on it with few RPGs and few machine guns. And this is the regime base, the Soviet base. Then they will come with 100 tanks, I don't know, 5,000 soldiers to come attack this place. Then from the place where they started to come to here, then Mujahideen would put one mine here and one here and one here. 2-3 tanks in trucks was destroyed by the mines. One tank was hit here, another truck was hit here, another, By the time when they will get to this place, they already lost 5, 6, or 8 vehicles.
Less willing than the Mujahideen to suffer casualties and surrounded by a country full of enemies, the Soviets needed something to make them less vulnerable: the rocket-firing Hind helicopter.
The Soviets have used their technical superiority to compensate for the ratio of their forces in Afghanistan. They have made extensive use of their Hind helicopters, which were completely invincible because of their armor protection. And whatever the Mujahideen had will not have any effect on these helicopters.
At first, the Mujahideen used handmade weapons produced in towns like Dara, Pakistan, where the only industries are guns and heroin. The Dashika was the Mujahideen's original anti-aircraft weapon, but it was no match for the high-tech helicopters. One weapon could do the job: a handheld heat-seeking missile called the Stinger. In the mid-1980s, the U.S. began covertly supplying Stingers to the Mujahideen. The balance of power began to shift.
For a Stinger, helicopter is just a sitting duck. If it is within the range of the Stinger, then the Stinger operator, will aim it. Aim at a Stinger, then go for a super elevation, then he will make adjustment according to the movement of the helicopter. Then you fire, and you will see a big explosion. Flames and smoke will go up.
For a period of about 100 days after the introduction of the Stinger, the Soviets were losing 1 aircraft per day. 1 aircraft per day. This drove this into the high-cost arena in a hurry. And as a matter of fact, the impact of these kinds of losses was significant from a number of ways. Not only the hardware losses, but the fact that morale started to go down. Transport pilots wouldn't fly. For a period just prior to the removal, extrication of Soviet forces, Stinger gave Mujahideen a decided edge.
The Soviets were vulnerable to the Stinger, but the Mujahideen had little to fear from Soviet smart weapons. After all, they had no tanks or aircraft for smart weapons to hit. The lesson of Afghanistan was bad news for U.S. military planners. If the Soviets could be neutralized by smart weapons, then so could we.
If you have that feeling to sacrifice for your country, then I think superpower or no superpower, it cannot stop you. If you're willing to die, that is the most important thing. But if with that feeling is combined with a smart weapon, then the superpower is gone.
We used to see industrialized nations, if you want to go back to the 18th and 19th century, who were able to easily overwhelm primitive nations, and that's the way that empires were built. But today, there's not such a great difference. The gap is closing.
Smart weapons are proliferating rapidly. Many of the stingers sent to the Mujahideen wound up in countries hostile to the U.S., like Iran.
It would be easier to probably say who didn't have smart weapons and try to list all of those that do have smart weapons. Smart weapons are supplied by all the industrial nations in the world. For example, United States, Soviet Union, France, certainly, Italy, Israel, Brazil, South Africa, England, the list goes on and on. All of these countries are involved in it because it's very commercially attractive to them. If Nova wanted to buy a smart weapon, I think that they could do it within a very short amount of time. If you got the money, you can buy the material. That's the bottom line.
It is an anti-tank weapon system. Short range, about 600 meters. And with this system, we can simulate all the targets at each distance, each speed, and configuration.
Could you aim at something for us?
Yes, if you want. You have to aim the target.
As far as what Iraq has had access to the world markets. What would that be? That's the French, the infamous exocets. It's the Chinese, the infamous silkworms, and it's the Soviet stick systems. The open press has informed us that the Hawk missiles and possibly Stingers have been acquired by Saddam Hussein when he took over Kuwait City. So, in fact, we may see the Hawks coming back at us.
In the new high-tech arms race, the U.S. is determined to stay a step ahead of countries like Iraq. Dr. Jasper Lupo works at the Pentagon's Defense Advanced Research Projects Agency. Here, he is developing the next generation of computer-driven weapons.
It's possible to think about a whole new class of weapons that literally go out and hunt and look for targets, and then fire only if they find targets, and may come back and be recovered. And what you can envision then is a low-flying 2,000 to 3,000 pound cruise missile that hunts around in the target area. Once it finds a target, it tells one of its little warheads to blow it up.
This is the battlefield of Dr. Lupo's robotic weapon, an 80-foot-long terrain model in Orlando, Florida. Here, the robot's computer brain is being programmed to hunt for targets by itself. Existing smart weapons have to be aimed toward a target, but not this one. Instead, it will fly around at hundreds of miles per hour, searching for an enemy, just as if it were a pilot in a plane.
It's completely unprecedented. It's never happened before. You have to go to science fiction, H.G. Wells' War of the Worlds or something to get even to get a feel for what it's like.
On the terrain board, the robot's targets are model missile launchers. Images come in from an electronic eye traveling over the model, simulating the actual robot in flight. The robot's computer has been programmed with a diagram of a missile launcher, the red figure at the top of the screen. It tries to match this diagram against the images it sees. When it has a match, the robot's electronic eye circles back to simulate an attack run on the target. If the computer software can be perfected, it will be loaded into a missile. It's conceivable that within 10 years, the weapon could be used for special missions.
For example, a training site for terrorists somewhere. You might want to suddenly be able to eliminate or damage a training area.
The robot's hardware is already being tested. In this practice run, a missile is launched at sea. It flies hundreds of miles to attack its targets. Without advanced software, the missile can't recognize the targets once it reaches them. It is simply navigating to pre-programmed coordinates and blindly dropping bombs. But the test does suggest the power of robotic weapons that could hunt and kill on their own.
You hover around, you hang around, or you visit several areas in the course of a mission. That means that the enemy never knows when these weapons are going to be there. And he may be moving when they kill him, or they may be hiding in the trees or near the trees when the weapon finds them. But the point is that there's sort of no rest then for the enemy.
One of the really scary things about smart weapons, and one of the things that people don't think about very much, is the psychological factor. It is one thing to be hunted by a man who has a wife and parents and children and dreams and ideas. It is another thing entirely to be hunted by a machine that simply thinks of you as a target. Worst of all, to be hunted by a machine that's patient and can wait and doesn't care that you're a living person with dreams and hopes and a sweetheart and children or whatever. It just knows that you're something that it wants to kill. That is truly scary.
Robotic weaponry is designed to replace human brains with electronic ones. But can weapons which work under artificial laboratory conditions also work on the battlefield, where accurate information is a rare commodity?
The smart weapons and these intelligence collection and communication systems all assume that all the information you get is good information. You're going to know precisely what the threat is out there, how to attack it. Never happens. My first rule in any combat situation was the first report, the first information to come in was always wrong. And I have no reason to believe that because we have smart weapons, we're going to get good information that will enable us to fire these 60 or 200 miles and it will unerringly seek out the target we want to destroy.
It's 7 a.m. at an airfield in Saudi Arabia. For the next 16 hours, this Air Force flight crew will man a flying command post, an AWACS radar plane, which will circle over the desert south of Kuwait. At any given moment, one or more AWACS is always in the air, ready to coordinate and direct U.S. planes and their smart weapons in any war against Iraq. The AWACS pilot and commander is Colonel Thomas Bliss. Currently at his disposal is a squadron of F-15 fighters, called CAPs, flying alongside to protect against an attack by Iraq's Soviet and French-made jets. But in a war, Bliss would be directing hundreds of U.S. warplanes.
The AWACS is designed to be the primary command and control platform to conduct the air battle from, and it's fed all the appropriate information. It has all the capabilities, both communication and command and control, and weapons control to conduct the entire air battle across all the roles and spectrums.
To know where to send the F-15 caps, the AWACS receives intelligence from spy planes and satellites. The AWACS also has its own radar to look hundreds of miles into Iraq, an advantage over Iraq's radar systems, which are mostly designed to track aircraft within its own borders.
This area down in here is Saudi Arabia. The upper portion of it is Iraq. This little area right here is Kuwait. Right now we've got an possible Iraqi fighter right here getting ready to go into one of the bases up there headed north.
The AWACS radar cannot actually tell one plane from another. The crew must decide what is and what isn't an Iraqi fighter based on airspeed and position. So far, it's a routine morning with no unusual activity over Iraq or Kuwait. The hours drag on.
How you doing, lady?
Where's the router?
But then, 12 hours into the mission, something unusual appears on the screen.
Okay, we just picked up a track in northwestern Iraq as a high-fast threat type fighter, and it's moving down to the southwest towards our position and our caps. So we are positioned in the AWACS and the caps to counter the threat in case it comes south across the border. Got to make a pretty fast decision because he's moving over 1,000 miles an hour right now. You gonna move the two ship that has the big old time to the west?
Sir.
By the time we do, they'll be out of gas.
Right. Iron 1-1's established Alpha Delta 2. We're going to get shadows and the shadows on Alpha Delta. Iron 1-3 ship, 2 ships heading home. We got Iron 1-1 for about 12 more minutes.
Okay, the aircraft is just accelerated from around 1,200 to 1,500 miles per hour, and that's a considerable threat, and so we're keeping a close eye on it.
But just before the Iraqi fighter reaches the Saudi border, it turns around and heads back to its base. Its mission may have been to probe U.S. defenses.
It's a little bit of an endurance test, as you might be able to tell up here. You got to be able to stay alert and pace yourself for the 15 hours that you're up here, and be sharp, as well sharp in the first hour as you are in the last hour to respond if necessary.
What do you think? He's not going that fast. What do you think? He's not going that fast. No.
Today, the AWACS crew has enough time to respond calmly to unexpected threats. But even if one plane got through, the results could be catastrophic.
Still have time to get his butt out of there.
In the Arabian Sea, no one on the USS Independence is taking the Iraqi threat lightly. Here, crew members stage a disaster drill to prepare for a hit by an Iraqi anti-ship missile. A fire detail rushes in to practice fighting what would likely be a raging fire. It would only take one Iraqi missile to wreak havoc on the ship.
As far as an anti-surface from the air, he has a very formidable capability. In this area, he has acquired again the French systems, the Chinese systems, which are very long-range standoff systems capable of being launched in excess of, let's say, 100 kilometers against U.S. ships, and I'm sure he has hundreds of them.
But the threat from Iraq's smart weapons isn't just against ships. U.S. warplanes will also be at risk from several varieties of anti-aircraft missiles based in Iraq and Kuwait. To counter the threat, the U.S. will use these smart missiles called HARMs. They're designed to home in on a radar beam, ride the beam all the way down to a radar dish on the ground, and knock out the enemy's air defenses, at least in theory.
I think it's going to be very complicated, if not impossible, to ensure ourselves that we can take out a large percentage of the mobile anti-air defenses that Saddam Hussein has put in place. He's not a dumb person, and his stratagems know that they need mobility, they need to move things, they need to camouflage things, and we don't know totally if anything about what he's doing in these areas. So it's very dangerous to assume that we can take out all of his defenses. I don't think it can be done.
If U.S. fighter pilots can't knock out Iraq's air defenses, they can still try to jam the radar of incoming missiles with special electronic equipment on board their aircraft. It's smart weapon versus smart weapon, computer versus computer. This is the USS Valley Forge, an Aegis-class cruiser built specifically to protect other warships against smart weapons. In a sense, the ship is the epitome of high-tech weaponry, with its smart torpedoes and missiles. Its massive phased array radar and banks of mainframe computers enable the Valley Forge to search constantly for enemy threats. But there are no windows in its command center, no views of sea or sky.
Older days, if you will, as I tell my children, before you had automation and before you had radar and sophistication like here, the captain spent most of his time on the bridge. He was directing the battle from up there where he could see things with his naked eye. And here the battle takes place so far away, you can't see with your own eyes. You need to use electronics, the radars, the sonars, all your sensors, long-range link with other ships in order to do that kind of engagement. This is the only place you can see it. This is the only place you can control.
38 seconds.
In this training exercise in the Pacific, the crew practices its split-second timing. With almost no warning, the Valley Forge must be ready to shoot down an enemy warplane while the plane is still too far away to launch its smart weapons.
All stations TAO, the key is inserted.
The need now has changed from being able to succeed just by destroying him at 5 miles or 2 miles or 100 yards from the ship. Now we're talking about having to destroy him at several hundred miles from the ship because technology has said he can now launch a weapon from those ranges.
An enemy can be hundreds of miles away at the moment, but in a few minutes, close enough to be very dangerous to you. So your decisions are much more rapid. You can make terrible mistakes.
The great dilemma of smart weapons confronts Captain Bozelli every time a distant plane appears on his screens. Although he has only a few moments to decide whether or not to fire, his computers cannot tell him if the target is friend or foe.
There it is. There's your missile. Seconds to intercept.
In many respects, it's easier in an all-out war. Anyone who comes to a certain area becomes the enemy. In the open ocean, it's easy. Anyone who shows up is the bad guy unless you know he's yours. When you get close to land or in scenarios where you're not arbitrarily shooting first and asking questions later, it is in fact a much more difficult problem.
In 1988, another Aegis cruiser was in the Persian Gulf. A Navy camera crew was there at the time and shot this video. The ship, the USS Vincennes, had been firing on Iranian gunboats. Suddenly, its air defense system detected an unidentified plane taking off from the distant Iranian mainland. The plane was climbing, not diving like a hostile warplane. But even though it was dozens of miles away, it was already close enough to fire a missile.
009, true, 5 miles.
The ship radioed in English to the unknown pilot. There was no reply. The Vincennes radar could not tell if the plane was friend or foe. The plane was still over 20 miles away, but closing. The Vincennes decided to fire before the unknown plane could fire first.
Oh, dead. We had it, got it. That was a dead on. Keep the noise down.
The target was not a warplane, but an Iranian passenger jet. All 290 on board were killed.
Here we had this cruiser with a missile system designed to be operated over 200 miles of sea and airspace, trying to fight a war in a little bathtub. And because of the compression of time, they made a very bad decision. We shot something we didn't want to shoot.
It's not my job to talk about Vincennes, but we've all been there and understand what's involved in making difficult choices. And that's all it is, it's difficult choices. For the decision maker, what technology has done is made his job considerably more complex. He not only has much more data now that he has to assimilate with the same brain he had 10 years ago or 20 years ago. That data does not provide perfect information. We are putting a lot of pressure on decision makers and those who support them to be infallible, and the human body isn't ready to be infallible.
Ultimately, human fallibility is the context in which smart weapons must be understood. This is Fort Irwin, California, in the Mojave Desert. Here, in the world's most authentic combat exercises, U.S. soldiers learn what might happen in a battle with Iraq. These are the same conditions, the same tactics, and the same kinds of military hardware that the U.S. would face in the Middle East. It's as close as you can get to simulating a battle with Iraq without shedding blood.
I feel euphoric. It's an exciting thing to be out here. This modern battlefield is very lethal. It's wonderful to be able to experience this without actually getting killed.
Positions, he will not have sufficient time to move against us. I'm concerned first about our alignment as we come out here, John, and your ability to make it to the decision point according to schedule. You are the guide for movement up to the point where we...
These Army officers are permanently stationed at Fort Irwin. Their job is to play the part of the enemy in elaborate mock battles. They use Iraqi-style tactics and hundreds of tanks and helicopters, just like Iraq's.
But not heavily obstacle the forward position of that. What you may see then is he expects us to come over the well.
20 miles away, the other side is ready to fight. It's a visiting unit imported to Fort Irwin for training. It will play the part of the American forces, using the very latest in high-tech weaponry. At 7 a.m., the enemy begins to attack. Equipped with outdated smart weapons, it can't hope to outgun the American forces. But thanks to its greater experience, it can outfight them. In this morning's attack, the enemy hopes to send 160 armored vehicles to outflank a smaller force of Americans and capture an objective 30 miles away. The battlefield is hundreds of square miles. Soon it's obscured by dust and smoke. At 7:30, the enemy forces begin to fire as they advance. Their targets are sophisticated American tanks, still several miles away. Although the Americans have smarter weapons to make up for their smaller numbers, they face not one, but two opponents, the enemy and confusion.
Confusion is something that you will find on every battlefield out here. We see the fog, the smoke,
people shouting on the radio. It's very difficult to try and figure out what's going on. That results in incorrect decisions being made by commanders, and that's why people get killed out here.
The less experienced American forces quickly become disorganized. Lacking accurate information, they don't know where to aim their smart weapons. In contrast, the experienced enemy forces keep to their battle plan and continue to gain ground. 2 hours after the attack begins, the enemy forces wipe out the last pockets of American resistance to achieve total victory.
I don't feel comfortable thinking that machine would replace man on the battlefield. In fact, even now, sometimes we find that soldiers get a kind of vertigo when they're inside some kind of a mobile shelter looking at a television screen and moving dots around and so forth and pressing buttons, and someone says, "There's an enemy patrol outside." What do you do then? No screens are helpful for you. This happens even now. I think really, for lots of reasons, the hand of man better be in the battle and the mind of man, or else things could go terribly wrong.
In Saudi Arabia, the Air Force technicians who maintain smart weapons wait for a squadron of A-10 attack planes to return from a mission.
Now just fighting aboard them. Takes attention now, throwing rocks at a big target. Makes us feel better. Working on my second career. Put some more rockets out here, though. We'll hit them. We can get them.
In high-tech warfare, technicians are as essential as combatants. But no matter how competent these technicians are, no matter how sophisticated their smart weapons may be, a war with Iraq or anyone else cannot be won with technology alone.
As far as the air capability and the superiority of air in that area, there's no question that we have that. Can air take out tanks? I think there's no question about that either. Now, once the tanks are taken out, there's no place for them to hide. Once the tanks are taken out, what happens now? It becomes a ground problem. And the ground problem is the one where Saddam Hussein certainly has the edge, both in not quality, but in quantity. And it'll become a ground battle, door-to-door battle. And that's the one the American public won't like. It's the one with a lot of body bags.
What you get over there? Ham slices?
I got ham slices, fruit mix, caramel. You can have everything but the John Wayne bar. Can't do it. Hey, I got to have that John Wayne bar. Can't leave home without it.
Got it.
And my grape Kool-Aid for my water.
Sad part, as a bachelor, I'm eating better out here. My microwave.
Somebody melted my chocolate today.
These soldiers in the 24th Mechanized Infantry are on the American front line in Saudi Arabia, 60 miles from Iraqi troops in Kuwait.
You can't beat this.
They're relaxed and confident now, but they know that if war breaks out, they, not smart weapons, will bear the brunt.
Yeah, the concept of a war that can be won by superior technology and a stunning blow simply isn't a true picture of warfare. War is conflict with blunt instruments, and people get killed and things get destroyed, and you don't win until you've killed more of them and destroyed more of their equipment than they've killed and destroyed on your side. If it was simply a case of signaling the other side that, look, we're superior, we've got all these brilliant new weapons, surrender, fine, he'd surrender, but he isn't going to. And we're going to have to use the weapons, and some of them will work, some won't work, and we'll fight a war of attrition. You attack, they defend, and people are killed on both sides.
Funding for NOVA is provided by Lockheed, a bold new force in systems engineering, management, and technology services for defense, space, and industry. And the Johnson & Johnson family of companies, supplying healthcare products worldwide. Major funding for NOVA is provided by the financial support of viewers like you. For a transcript of this program, send $5 to this address or call 212-227-READ.
This is PBS.